machine doesn't perform very good operations with very large numbers. So to handle matrices with really big numbers, I did the row normalization. I implemented a backtracking code, which is this function. So what it does is it gets the last number of the row. So in this case, it would get this number, and in the next row it would get this one and this one. And what it does is for every number that is in the vector x, which is the vector that has the solution, it performs a subtraction, but for the first one, so we don't have any number in this vector, so we just add this number, which is the sum divided by this number. So the result is 3. Then when we go to this number, which is the sum, then what we do here is to subtract this value by this value, and then we get the value that we have to divide by this number. So this number gets subtracted by this, multiplied by this, and this multiplied by this, and gets divided by this number, and at the end it's 1. So now this is my function which performs pivoting. So I chose the two-loop one, and what it does is it gets the maximum searches for the maximum value in the column, and it sets that row to the so this is my forward to loop pivoting function, which is a function that performs pivoting, which helps in some cases. So the main idea of this code is that it gets the maximum value of the column and moves the row, so the pivot is set to the maximum value possible. And then, well, here we swap, so we set the pivot to the biggest value of the column, and then we normalize, and then we perform what we did in the first lab to get 0. And this, what it does is that in some cases it helps us to solve some systems like this one, which is done with a function of the first lab, the two-loop function, and we don't get the solutions because it's not adapted to the backtracking function. So if we use partial pivoting, it adapts the triangulated matrix to the backtracking function, so we get the values. And here I have this function, solve factor elimination, which what it does is it checks the type of system, and then depending on the type of system, it performs the backtracking or not. So what it does is to set this string to the return value of this check system type, and if it's compatible, it performs the backtracking, and if not, it doesn't. This is my check system type function. So first of all, we have a float named limit, which we set to 10 to the minus 8, and we will assume that this limit is 0. So first of all, we get all the values except the last value of the row, and then we set this last value variable to the last value of the row. If all these values are 0 and the last value is bigger than 0, it doesn't make send, because 0x plus 0y plus 0z has to be true, so we can state that the system is incompatible. But then if all of these are 0, we can't stop the function, we cannot, and tell it to terminate, because we don't know if we have an indeterminate row. So if we don't find any of these, then we set the system to indeterminate, and if we don't set the system to incompatible or indeterminate, we set it to compatible. When we have, for example, an incompatible system, it detects that it's incompatible, that has no solution, so we don't call the backtracking function. And here we have an indeterminate system, so it doesn't call the backtracking function.